Today we are going to talk about the standard normal distributions, and then we are going to learn some properties about it. We are also going to leverage on the standard normal distributions to be able to help us solve some distribution parameters. So that is what we'll be doing today. So we all know that a normal distribution is symmetric. The standard normal distribution, it's a special case of the normal distribution. So anytime we have a standard normal distribution, it means that it's a normal distribution that has a mean of 0 and a standard deviation of 1. And so we usually denote that by, so this N here stands for normal distribution, the 0 stands for the mean, and then the 1 stands for the standard deviation. We could also have normal maybe 2, 1. So this is a normal distribution with a mean of 2 and a standard deviation of 1. This is not a standard normal distribution. Standard normal distribution has a mean of 0 and then a standard deviation of 1. So for example, let's look at this curve here. So the mean is the center. So here is what? 0. And so the space under the curve, so this space here, is what we call the area. Is that okay? So then that is the area. And so the total, and then this area represents probabilities. So the total area under this curve is what? 1. So you should always know that the total area under the curve is always 1. So what it means is that if you have a standard normal, and then let's say this is 0, this area here is 0.5. This area here is also 0.5 because the total area has to be what? 1. Any questions? So if we have, this is a standard normal, and then we have this place, and then this is an area. So this area is between these z values. Is that okay? This area here is the probability between these two values. So for example, so let's look at a more concrete example on that. So when you look at this one here, we can see that the z value here is negative 1.5. The z value here is 1.5. And then this shaded area in pink is the area between negative 1.5 and 1.5. Is that okay? So this shaded pink here is the area between negative 1.5 and then 1.5. So how do we write that? So the probability between negative 1.5 so that represents this area here. And also, sometimes too, you can be given the area and then you'll be asked to find what z value corresponds to that. Is that okay? In this situation, we have the z values and then we are looking for this area. Does that make sense? There are some situations you'll be given this area and then you'll be asked to compute those z values. So for example, here, this is a standard normal. We want to find the area between negative 1.5 and then 0.5. So let's get to StatCrunch. So open your StatCrunch. Now this is what the standard normal. So when we get to StatCrunch, let's get to stats, go to calculators, and then we get to normal. Now we are dealing with the standard normal. So make sure that the mean is 0 and your standard deviation is 1. Whenever we do that, we are looking for the area between negative 1.5 and then so let's get to between and let's put negative 1.5 here. And then we put 1.5 here. And then we hit compute. So I got 0.8666. Did you all get that? Good. So you see, in this example, we have the z values. What we computed was the area shaded in red. Does that make sense? There are some problems you'd be given the area shaded in red and you have to compute the z values. Is that okay? Good. So let's proceed. So anytime we want to, so if we have our standard normal here, and then anytime we are given an area and we want to compute the z value, we always want to compute the area to the left. So for example, if we have this thing here, we want this z value, we want to what? Have this area to the left of the z. And then we can use StatCrunch to compute this z value. So which means that you'll be given this area, say here could be 0.2 or point something. I repeat again, in the first problem, we had the z values and we computed the area. Now, there are some problems, it's the reverse. You'd be given the area and you want to compute the z values. Anytime you are given the area you want to compute the z values, the first thing you have to be able to do is try to compute it using the area shaded to the left of the z. Is that okay? We want to compute it to the area to the left of the z. So for example, if I want to find what, if you want to find, say, we know that probability of z is greater than, what z value here gives you an area of, say, 0.5. Okay? So it means that if we try to sketch that, you should always try to sketch. And then here is that z value. And then remember, here is greater than 0.5. Here is 0.5. But because we want to use the standard normal table to read or read from StatCrunch, we want to focus on the area shaded to the left. So we want to focus on this area here. If we have this area here, the complement here should give you the area to the what? To the left. If here is 0.5, here would also be what? 0.5. Is that okay? Because the total area is what? 1. If here is what? 0.2, here will be what? 0.8. Is that okay? So anytime you want to read this z value here, always focus on the area shaded to the left. Does that make sense? Let's proceed. So the first example we did, we want to try to do this. let's try to know the z values that contain the middle 90% of the normal curve. So let's try to do that. And then let's draw a picture and show this. So before we do that, let's draw the standard normal table, standard normal curve. So we have this here. Okay? And we are told that the middle is what? 90%. So if the middle is 90%, it means that this shaded region here is 0.9. Right? That is what we are told. We are told that the middle is what? 90%. If the middle is 90%, what will this side be? What would here be? What is this area? 0.05? What would this area also be? 0.05. Because we know the total area is what? 1. If the total area is 1 and here is 0.9, and then this is divided into 2, here will be 0.05, here also be 0.05. Is that okay? And so we can see that here is z 0.05. So to the left is z 0.05. And then here would be z. What would it be? So to the left of all this is what? 0.95. Does that make sense? Does that make sense? I always tell you for the z value, we focus on what? The area to the left. Here to the left is what? 0.5. Here to the left is 0.9 plus 0.05, 0.95. Is that okay? Make sense? Okay. So these are the fundamentals that you have to be able to know. And so I decided to draw a picture just to show you. So this is Z 0.05. This is Z 0.95. Okay, now that we have learned this, so now you can be able to read, right? So let's try to read from StatCrunch. So for us to read from StatCrunch, it means that this area here is 0.05, right? And then the whole of this area here is what? 0.95. So let's try to find z of 0.05 and z of 0.95 in StatCrunch. Does that make sense? We want to find those z values. Does that make sense? So let's try to find that. So let's get to StatCrunch. So we are in StatCrunch. Let's get to standard. So now make sure that you have your mean to be 0, your standard deviation to be 1. And then in place of the 0.5 here, put the area. The first one is 0.05. Is that okay? And then you hit compute. So it gives you negative 1.645. Is that okay? So what it means is that it means that z 0.05 is equal to negative 1.6445. Right? 448, not 5. 448. Now I want you to read Z 0.95. I have explained to you why here is 0.95 and not 0.05 because we want to read the area to the left. Is that okay? Here is 0.9 plus 0.05. That gives you 0.95. Now let's go find the Z value for Z equals 0.95. We come to the standard normal. Anytime you get to the standard normal, make sure your mean is 0, standard deviation is 1. And then let's change this 0.05 here to 0.95. And then we hit compute. And then that is what? Positive 1.6448. So 1.6448. So these are the Z values. So in place of Z 1.95, I could put I could put 1.6448 here. And then in place of Z 0.05 here, I could put negative 1.6448. Does that make sense? Mm-hmm.
Z 0.05. Is that like 5%?
Mm-hmm.
Totally grad.
Yeah.
And negative 1.64. That's the
That's the exact Z mark. Yeah. Good. So now we've learned two things. We have learned how to compute the area. We have also learned how to compute the Z values. Does that make sense? Okay. So now that we have these two skills, we are going to implement that by learning how to apply them on other normal distribution by standardizing them. So for example, let's look at this example here. Now I want to apply them to compute unknown parameters. So before we do that, I'll do this example and then you do the subsequent ones. So we are told that the scores of the final last semester had a mean of 70. So we know mean 70, right? We are told that 75% of the students scored below an 82. So let's say that if X is the scores, it means that probability that X is less than 82 is 0.75. Do you all agree with this? And we are asked what is the standard deviation? For us to be able to do that, we will try to standardize this. So before we do that, let's try to represent this information on the graph. So let's do that. This is my graph. This graph here is not a standard normal. Is that okay? Because the mean here is 70. Is that okay? And then let me put my 82 here. Say 82. What it means is that the whole of this area here is what? 0.75. Do you agree to that? You agree to that? Okay, good. Now, since we have this, let's try to replicate this in the Z form, in the standard normal form. Same graph here. And then let me put this thing here. What's Z value here? And then the area here is what? 0.75. Is that okay? So now I want you to compute what Z value gives you an area of 0.75. Let's get that Z value. Here, we don't need to do anything because the area is to the left of Z already. We can see that. Does that make sense? So since the area is to the left of Z of that, what Z value gives you an area of 0.75? Is that okay? Here we know X is what? 82. Okay. Now I want to find the Z value, the standard normal value. So let's try to get that. Let's get to, so you can go to start crunch and then you can do that. So let's go to start crunch. And then make sure that your mean is 0, standard deviation is 1, and then change this area here to 0.75. Okay? And then hit compute. What do we get? 0.67448. So we know the z value here is what? 0.67448. Any questions so far? We all okay? Right. Okay. So now that we have this z value here, remember on Monday we learned that z is equal to y minus y bar over this. We can be able to check that in our slides. Do you remember this? So since we have this, so now that we have this z value here, we have this z here. So now we are going to do z is equal to y minus y bar divided by the standard deviation. Okay? So now we are trying to what? Standardize this 82 here to be equal to what this z value here. So to do that, we know this z value here is what? 0.67448 equals our y here. The y here is 82 minus the mean. Look at this y bar. Y bar is the mean. The mean is 70. We're given the mean value to be 70, isn't it? What is the standard deviation? We do not know. Now we can solve for the standard deviation. So to solve for the standard deviation, what do you have to do? Multiply both sides by this sigma. Is that okay? Now the rest is algebra. So if you want to multiply both sides by sigma, we get 0.67448 sigma equals, what is 82 minus 70? 12. Now, if I want this guy, what do I need to do? We divide. Is that okay? Divide both sides by 0.67448. So this implies that sigma equals 12 divided by 0.6748. And what do you get for that? I got 17.8. Did you all get that? Any questions so far? Is there any procedure you don't understand? So I could explain again. Are you all good so far? Okay. If you are good, then I want you to try this problem. Remember, to get a z value, read to the left. Is that okay? So I want you to try this. That's you. Anybody wants to share the answers? It's okay to get it incorrect. It's good to share what you think you got. That way you can learn. Anybody? You want to share yours? Just feel free. Mhm. It's okay. 3.36. Anybody else? Mhm. 2.9. Anybody else? Just feel free. You want me to call names? What did you get? 68.6. Anybody else? Okay, let's do it together. I'm sure most of you also got answers, but probably you don't want to share, but that's okay. So let's do it together. So let's follow step by step. So how many of you were able to see that the standard deviation is 4? So we can see from here that the standard deviation is 4. Are you all able to see that? Okay. And what are we looking for? Mean, which we don't know, right? Okay. So the mean is, I don't know. Okay. That is what we are looking for. And then we are told that 20% of the males are more than 72 inches tall. How do you write that mathematically? P, let's say X, should be greater than or less than? Greater than, because we are told that they are more than. Is that okay? 72 is 0.20. Do you all agree with this? We all good on this one. Okay. Now, if you're all good on this one, looking at this, I want you to draw the curve. Look at this one. When it's less than this, I shaded this area. So for this, where would you shade? Do you get my problem? My question. My question is that for this one, here, scores below 82, I shaded this place. Is that okay? And so for this one, where would you shade? You shade to the right. Do you all agree on that? Okay. So let's say that here is 72. So you guys are saying that if a sense says 72 is greater than, I'm going to shade here. Here is what? 0.2. Right? Is that correct? Okay. So what did we do? We decided to look for the equivalent Z, isn't it? So we come here. And then I put Z here. Okay? What did we learn about Z? The area should be to the left of Z. That is one key thing. Is that okay? What is the area to the left of this? If this is 0.2, here will be what? 0.8. Do you agree to that? And so then here would be 0.8. Are we all okay on this one? The first one, we didn't have to do anything because it's already to the left. Is that okay? But for this one, You guys got this one right. But remember that, okay, for me to get the corresponding z, I need the area to the left. Is that okay? And remember, the total area is 1. So if you have 1, you can find the complement. Is that okay? To get this. So here is what 0.8. Now read z. What would you get for the value of z? All you have to go is go to start crunch, put in 0 and 1 here, and then change this thing here to be 0.8. Does that make sense? And then we hit compute. What did we get? Okay, 0.8416. So our z value here is 0.8416, right? Now we have z. We just need to standardize this. So remember, z equals y minus y bar divided by this. Okay? Now let's do it together. Our z is 0.8416 equals our y here is 72 minus the mean, which I don't know. Let me put mu here. Or you could put x bar. So we didn't change it back to 1. We are just trying to get the equivalent standard normal. But for standard normal, the standard deviation is always 0 and 1. Does that make sense? This is already there. The standard deviation is 4, right? And I want the equivalent z. Equivalent z means the equivalent of the standard normal. For standard normal, mean is 0, standard deviation is 1. You cannot change that. That is why it's standard. Is that okay? Good. That's a good question, by the way. So you see, this is the equivalent standard normal. Okay? 72. Now we are doing 72 minus mu divided by, what is the standard deviation we are given? 4. Does that make sense? Now you can solve for mu. How do you solve for mu? If you cannot represent this by mu, you can represent it by any variable you want. Or you can say, okay, let me do, you can even clean this and put mean there and then solve for that. Is that okay? Does that make sense? So I know most of you are not math people, but just know you could put mean here. It's okay to solve for that. Is that okay? Yeah. But I'm a statistician. I prefer to represent it by mu. So we have this one here. And so what is the first step for us to be able to solve for this guy? What do you think we should do? Multiply by 4. Good. So we multiply both sides by 4. We get 0.8416 times 4 equals 72 minus mu. Okay? What is 0.8416 times 4? Anybody want to tell us? Okay. 3.336 equals 72 minus mu. What do we need to do to get mu? So to get mu, we could do mu is equal to 72 minus 3.336. Okay. So we had 72 minus 3.336. What would you get? 68.63. Is that clear? Okay. Now I want you to try this problem. So what I want you to focus on, try to get the z-scores. So let's try to get the z-scores. So we are told that the dog pound wants to know how old dogs are who end up at the pound. So they estimate that 25% of their dogs are less than 2 years old. Can we see this one here? Okay. So it means that if we are drawing a curve for that, and then here is, let's say that here is 2, do I shade to the left or to the right? To the left, right? Because it's less than 2, okay? What is the corresponding z-score? So here is what? 0.25. The corresponding z-score, this is z, this is also 0.25. What is the corresponding z-score? Negative 0.6744. Did you all get that? How many of you didn't get this? So you all got this one. Okay. Let's get to the next one. 10%. So now, do you agree that since this alone, it means that we have z equals 2 minus mu divided by standard deviation, right? Because we don't know the mean and the standard deviation, okay? And then this z here, let me change this z here and put negative 0.6744. Okay? Okay. Let's get to the other one. 10% of the dogs are more than 8 years old. Let's draw that one too. So we have that one here. And then let's put 8 here. Do I shade to the right or to the left? To the right, right? And so here is what? 0.1. But if you want the z-score, what would you do? We want the area to the left. Is that okay? So let's try to do that. It means we have this one here. And then z. So that means what is the area here? 0.9. And that is what we would use here. 0.9. What z-score did you get? 1 point. What did you get? Okay. 1.2815. Did you all get that? How many of you didn't get this? So I'll go to start crunch and do it. You all got that? Okay. So if you all got that, anytime you have the z-score, let's try to standardize this. So that means you agree we are also going to have negative 1, not negative, my bad, I'm sorry. So it means we are going to have 1 point, 1 point 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 1 1.2. I don't know why this is messing up. We have 1.2. Two eight one five equals 8 minus mu divided by sigma. So we have these two equations. So let's try to set them up. I think it's almost time, but we ended here. So Friday would continue from here.